Hello friends, so in this video we will check for the prime numbers and we will get input from the user, and after that we will check from the user that if that number is a prime or not. And first I will use a normal approach where we will like loop every number, but after that I will show you how we can optimize our code, and I will use the optimize approach to get the prime number, and which will be lot faster than the normal one, and the performance will be much more increased if we use the normal approach. Let's say if you have a large number of let's say if you have 1,000 or 2,000 numbers you have to check, or 10,000 numbers you have to check for the prime numbers, then in a normal case there will be a lot and it will be time consuming and the performance will be slow. More CPU will be used, but in optimize approach this will be a lot faster. Okay, so let's start. I have already created the prime number checker folder and which is currently empty, and we will create our C file and start including the header file. We will and the only variable we need right now, because we are getting the input from the user, which will be a number, so I will declare a number here and we will just use a printf, enter a positive number, and we will get the input from the user by doing that, pass the reference of the number. So one or less than one number are not a prime number, so we will first check that if the user passed the 0 or 1 number less than or equal to 1, then we simply mention to the user that this is not a prime number, and we will just terminate our code here. Okay, so for that we will check the number is less than or equal to 1, then it means that it's not a prime number. Okay, for that we will do that is not a prime number, and we just simply I haven't passed the number, we have to pass the variable number here, and we will just simply terminate our code here. Okay, I think we will do that. Okay, and after that let's say if the user passed the numbers 7 or 10, we have to loop each number and to check whether that number have any divisor or not. Okay, so the prime numbers are only divided by itself and the 1. Okay, so any other divisor if you found, then it means that number is not a prime number. For that we will use the loop here, and we will declare okay. So one more thing, this loop will start from the 2 because we have already checked that the number 1 is not a prime number, so or also less than a 1. Okay, so it doesn't make any sense to start a loop from the 1. If you start the loop with 1, then you will get every number is not a prime number. Okay, we have to start it from the 2 here, and for that we need to make sure that number is less than number, because that number itself will be not included, because the let's say user passed the 7, the 7 itself is a device. If you divide 7 by itself, then you will get that it will be equal to a 0, there are no remainder left. Okay, so it means that number is a prime number, so we will neglect that last number which we have with the user passed, because we know that we can't divide that number by itself. Okay, so we will do that just by checking sorry about that. Okay, and we will look check the condition here. If the number is divided by I equal to 0, we didn't get any remainder, then it means okay. So now I think we need some kind of a boolean variable here, because if this condition gets true, then it means that number is not a prime number, so we have to store something in for that, any kind of a flag here. So for the boolean in the C we don't have the boolean data type. For that we need to include the std bool.h header file to use the boolean value to much cleaner and more readable, because we can use 1 and 0, but that will not look that much cleaner, and it will be confusing for most of the user, because every other programming languages have the boolean data type, and so we will use that. For that we can now access, we can have the boolean after including that header file, and we will just use this prime, and by default this will be true. Okay, so by default this will be a true, and we will do is prime equal to false here, because the number is not right, and we will just break the loop, because we don't have to loop other condition to check other numbers for now. Okay, because we got the that, because if any other number we found out that it is divisible of that number, then we have to break that loop. Okay, and now we have to prompt the user. For that we will say that is prime, then it means that number is prime number. Okay, so person E is a prime number, and we will pass the number variable here, otherwise in else case, and we will check that is not a prime number. Okay, so we don't have any errors, so let's just test this out. Okay, and we will just test this. We compile it successfully. Now first we will pass the 1, so 1 is not a prime number. We will try to execute again. Now it's prime. 7 is a prime number, so we will try to check for the 7. 7 is a prime number, which is perfectly fine. Now we have to check, like, because this was a quick, if you see I passed this 7 number, 7 is a prime, it just quickly execute everything. And let's say this time I passed we have number 1000. Okay, now check this time, 1000 is not a prime number, and let's say we increase the number by 100,000. It's quick as well, and if we pass the number of 0, but this is not the, I know the speed is faster because we only have a one loop. This code doesn't have any other kind of the loops or anything for which it needs the execution speed, but this is not the optimized way. Right now if I show you the code, we are like, if I'm passing the 1000, then we are checking every number until 1000. There is a better approach, the optimized approach, which we will use here. So for that we need to include the math.h here, and we will check here. The only thing we have to check here is that square root of number I less than or equal to square root of that number. Okay, so this is the trick for the optimized approach. It means, let's say we pass the 36 number, so this loop will only execute for the 6 times, because the square root of 36 is 6. Okay, and if there are any divisible of that number, we will get that until the square root of that number ends. Okay, and this is the case for that. Now let's say if I pass the 36 here, and before it was a normal code, the 36 times this loop will get executed, but now it will only render for 6 times, and in 36 is not a prime number, because if we loop through 6 times, then we will get any not, if we get a single divisor of that number, then it means that that number is not a prime number. So if we pass 1000, then I think we just 1000 square root. Okay, so let me check. So it's almost 30. Okay, yeah, so 30 is the square root for the 1000. Then for 1000 only the 30 times loops will get executed. Okay, and if we find anyone on the first index, then loop will get terminated. Okay, just like the for the like the 1000 number we have passed, so the 1001 is only one we have got the loop, but this is not the optimizer. Right now I have passed this square root approach. This is the optimized way, and this is much faster for the performance. So let's just test this out. Okay, we will compile our code and we will check that number for 7 again. 7 is a prime number, and this time we will pass much larger number. It's not a prime number, and we will just pass the random sum numbers. Okay, it's not a prime number. Okay, and okay, so we have for square root we have included the complete library for math, which is the math.h, and behind the scene the square root function does a lot of more things, and we only need a square root. So you can do you can make your code just a little bit more better. Just by doing that, we will not use the square root. We will just multiply that index integer I with the I, and which will be less than or equal to number, not a, just a number. Okay, so this is the same as the square root. We are taking the square root of that number, and we will just remove that header, and we will test the code again. We will just compile our code. Okay, and pass the 7. 7 is a prime number. We will pass the 1. 1 is not a prime number. So now, as you can see, we have write a clean code, and that's why every other developer use a different approach, and that's why every developer codes, every coder codes is different from the other. There are so many ways of doing to write a program, but you have to find out the finest way, the readable, the efficient way. So we can include the math.h, but I think with this approach right now, which you are seeing on screen, is a lot far more better than using the just including the header file only for using the square root. And okay, so that's it for now. Thanks for watching. See you in the next video. Bye.